Hi guys, hope you're all doing well. We're on our lesson of 5.4, which is all about solving trigonometric equations. So I'm going to run through 7 examples with you. I may split it up into 2 or 3 videos, we'll see, just because I don't know exactly how long I can go for one video on this app. So I'll let you know what happens. Let's start with a relatively simple one. Example 1 is going to be solve, got the coefficient. Solve 2 sine x plus 1 equals 0. And we need to solve this on a domain where x is between 0 and 2 pi. Okay? So when we're solving, sorry, I don't like this plus sign. I'm going to make it neater. 1 second here. There we go. It's a little bit better. It's a little tricky to write with this stylus, but I'm doing my best here. Okay, so when we're solving an algebraic equation, our goal is always to solve for x and get an answer for x, a numerical value. When we're solving a trigonometric equation, our goal is going to be to isolate the trigonometric equation first and ultimately to solve for x as well and get a numerical value for x. In this case, let's try and get exact answers. So to isolate sine x, all we need to do is just move the 1 over, it becomes -1, and then divide both sides by 2. So sine x equals -1 over 2. At this point, what we're asking ourselves is for which angles does the sine equal -1 over 2? So we need to turn to our wonderful circle here. Now, we've gone through this before in chapter 4. Let's just recall the steps. So first thing we need to do is locate the quadrants where sine is negative. So sine would be, according to the cast rule, sine would be negative in quadrants 3 and 4. Correct? I'm missing your input here. Don't like talking to myself so much. Okay, so we're in quadrants 3 and 4 because we want sine to be negative. Next step, if you recall, would be to find our related acute angle alpha. So the angle in each of those quadrants for which the sine is 1/2. Remember that when we find our related acute angle alpha, we do not use the sine. We do not use this sign here. We eliminate that sign. So what we want to do is alpha equals the sine inverse of 1/2, not -1/2. And that will give us the related acute angle. In order to find this, I'm just going to go back to black here for a minute. We want to, oh, there we go. We need to use our special triangles, right? So for which angle is the sine 1/2? That would be pi over 6. And we want to keep everything in radians because our domain here is given in radians, 0 to 2 pi. So that related acute angle, pi over 6, goes in this quadrant and this quadrant. And now we need to find the angle x. That's the standard angle. So this would be step 3. We need to, let me just try that again. Sorry, 1 second here. Step 3 would be to find theta, the standard angles that go with those two related acute angles in the 3rd and 4th quadrants. So theta in the 3rd quadrant is going to be pi plus pi over 6, which pi is 6 pi over 6, plus pi over 6 would be 7 pi over 6. And theta in the fourth quadrant is going to be 2 pi minus pi over 6. 2 pi would be 12 pi over 6. Minus pi over 6 is 11 pi over 6. Okay, so we have now, oops, I'm sorry. It's not theta we're using, it's x. Let me change that. Here we go. So these are our final answers. X equals 7 pi over 6. X equals 11 pi over 6. And there's just one more thing that we should do. We should make sure that our final answers here are actually, one second here, that these final answers here are actually in the domain that we've been given, 0 to 2 pi. So you can just use your calculator, and 7 divided by 6 is bigger than 1, but it's not as big as 2. So that's fine. 11 over 6 is just under 2 pi. So we're good there. Now, if this domain was bigger than 0 to 2 pi, let's say, for example, 0 to 4 pi, then we would have to keep going to find more angles. And we're going to do an example like that later. So I'll go over that with you a bit later. Okay guys, we're on example 2 now, and I think I'm going to do this example and then cut the video and start a new one, just so it's not excessively long. So for this one, we want to solve this equation, secant squared x equals 2, and let's also do it for a domain of x between 0 and 2 pi. Okay, so we know that secant is 1 over cos. So if I want to change this to cos squared x, then all I'm going to do, since that's the reciprocal of secant squared, I'm going to take the reciprocal of 2, which is 1 over 2. So the reason I did that again is because this is the reciprocal of that. Oh gosh, can't write reciprocal. Anyway, never mind. Cos squared is the reciprocal of sec squared, so I do, sorry guys, I'm just getting used to using this app to do this, is the reciprocal of that as well. So reciprocal, reciprocal, okay? Whatever I do to one side of an equation, I have to do to the other. All right, now I want to isolate the trig function, which is cos x. So I'm just simply going to square root both sides. Remember to do plus or minus when you square root a number. And so that can be written as plus or minus 1 over the root of 2, since the root of 1 is 1. And now, since my answers are both positive and negative, I need to locate the quadrants, but I'm in all quadrants because cos is both positive and negative. So I should have 4 answers. To find my related acute angle, I have to do the cos inverse. Remember, no sign, just positive, don't do negative. Cos inverse of 1 over root 2, according to special triangle, is pi over 4. So pi over 4 in each quadrant is what I'm looking for. Once I have my related acute angles in the appropriate quadrants, I need to go ahead and find my standard angles that correspond. So first angle theta in the first quadrant is simply, I'm sorry, I'm doing theta again, it should be x. Somehow I like theta better, I don't know. Maybe I'll use theta for the next one. Okay, just get back to my pen here. Okay, x equals pi over 4, that's in the first quadrant. So that doesn't have to change. In the second quadrant, pi over 4 would be pi minus 3 pi over 4. Sorry, pi minus pi over 4, which is 3 pi over 4. That's in quadrant 2. So that's this one. Go back to blue now. In the third quadrant, it would be pi plus pi over 4, which would be 5 pi over 4. In the fourth quadrant, it would be 2 pi minus pi over 4, which would be 7 pi over 4. Now, remember our last step is always to make sure that all of these angles are indeed in our domain, which is 0 to 2 pi. And they are, because 7 over 4 is just below 2. 8 pi over 4 would be 2 pi, so we're all good.